So today we're going to talk about simple random sampling and smart methods, and then systematic sampling, stratified sampling, stratified random sampling, and the last one is cluster sampling. This is in your practice, but we go through it today. So simple random sampling is the simplest one. You're just sampling, let's say, n individuals from a larger population. And we will use this function, random.sample, like sample in a random library. Oh, sorry. Yeah, when we talk about 4 kinds of sampling, and then this one is in your example, I will go through it. So first thing, we need to load this environment. We use 3 package here, pandas, and a random. We will use a lot of this function, random.sample. So here we are getting a list here. So the list is start with the square bracket and then end with the square bracket. So this one is called list. So we have a list of names here. We stored it in a variable called names, and then we set a random seed 52 so that we can get the same results every time. So we're gonna sample from these names. So this function allows us to sample from names. This is the first argument, sample from this list, and then the 3 is our number. It's the number of samples that we want. So we store this to the list one, and then reprint the list. It will give Roger, Jason, Martina. And then if we change the random seed here, into 51, then it will give us a different sample. So you can see that every time if you don't change the seed and then you just run the function here, it will give us the same results. So the purpose of set this random seed is to produce the same results. So next, we change, next one is just to change the seed number here, change to 290,000, and give them different samples. So this one, we directly sample the names from the list, the name list. And then the next one, we can sample the number from these array. So we call this number array. So now we have this list and then range 8. Then we will have 8 numbers here, start from 0, because but the Python always start with 0. So range 8 will give us 0 to 7, and we make a list because we need this square bracket. If we don't have a list here, then it might just return to an array with the round brackets. So here we do the same thing. We set a random seed, and then we use this function, the random.sample. So this function come with a random library here. So it has to come together. If you copy paste this function, just don't forget any parts. So now we random sample from the sequence numbers and then 3, because we still need 3 number samples. And then we print it. It gives us a 7, 2. So there's 3 numbers here, and then we print it in this way, because this one is names is here, right? We define here name is a list containing these numbers, containing these names here, and then if you you can add a trunk here, add a code trunk here, and give 5 names, like 0, and we give a Roger, because the start with 0, right? It's the first name, and then like the last name is start with 0, and then end with 7, because there are 8 people. If you try 7, then it will give up lower. That's the last person. So the square brackets, and then the number within it, it gives us, so we call it index. So every person like corresponds to their like own index. So here for I in sample list 3, that means sample list 3, it contains 3 numbers here, right? Say 7, 2, and then for I in sample list 3, that means we selected the number 7, say 7 and 2, and then we'll give them this. Let me show you another chunk. If you do this, and then we print I, it will give us these 3 numbers. So I here, I in sample list 3 will stand for these 3 numbers, and then if we do this, like 6, it will give our Martina, right? So you see, and then 7, it will give a Lauren here, and then 2, it will give a John. So it just prints the names of this number. So there's a different way. So the first way, you just sample directly from the name list, and then the second one, you sample a number, and then this number is the index. It's kind of like ID, and then everyone has their own ID, so it will return to their name eventually. So here's the practice here. So the question said we got 10 observations. We need to sample 10 observations from the population of 100 IDs, and then using SRS, that's a simple random sampling. And then we don't have the name for it. We just need to sample the ID here. So we need to sample. We need to sample a range, a list of number here. So we use this. We give this population ID a range, because there's 100 IDs here. So range 100, it starts with 0 and then end with like that. And then we set residency here 1, 2, 3, 4, and then we sample call ID here, and then 10 numbers here. If we print it, then it will give us these results. These numbers and these numbers correspond to their IDs. And then next one is a 2D array. So if we run this, you can see that there's 2D arrays. There are 1, 2, 3, 4, 5 rows, right? And then 3 columns here. And then remember, it also starts with 0 and with, so here is 0, 1, 2, 3, 4, and then the column is 0, 1, 2. So if you print, so we store this array to the array to this variables, right? Array variables. So if you print array, and then first dimension maybe 0, second dimension 0, it will give us 3 because the first element is 3. And then if we do 4, 0, it will give a 9, right? So now we have 5 rows, and then if we want to select 2 rows out of 5 rows, then we'll do this. We use the second method, which is select a random number, which is select from the range 5, because range 5 will give us 0, 1, 2, 3, 4, right? And then we select these 5 numbers, and then we select 2 numbers from these 5 numbers. So we print it, it will give us 4 and then 2. That means the last row and then the third row, right? Because it start with 0. So we print this one, random rows here, it will give us the last row and then the third row. So as we said, like if we print this, if we do this, the column here, that means we selected all the columns, and then the row we select the second. So this function will select the second row for the whole row, and all columns. So give us the second rows here, and then if we do this, because this one is the same as this one, right? If we do 2 rows here, the 4 and then 2, corresponding to the last row and then the third rows here, it will give us the same result as this one. And then also it's the same. If you do column here and then maybe 2, because I only have 3 column variables here. It will give out the last columns here. So this means you select all rows, and then this means you select all columns. So that's for simple random sampling. And the next one is systematic sampling. It's like you obtain a sample by going through a list of population at a fixed interval. So it means that if you have the whole population here, you're gonna divide it evenly, and then from every interval, you're gonna select a person here. So here we're gonna build a data frame here. So we have faculty, gender, and the ID here as variables. So this is the way we build our data frame. We taught it in the first lab or second lab. So we have to create a list first. So this, all the names, they are inside the list here, the square bracket, and then also the gender here, a list. And then if you see this, I'm gonna add a chunk to show you. So if we only do this, it will give an array. So if we add this function to list, then we are making an array to a list. So then we can build this data frame. So we're gonna use this big bracket to contains all the information we need. Remember, this is a dictionary, and then so this one is our object, and then object value, and another variable object value, and then and then we use this function under the library data frame function. We convert this library into our dictionary into a data frame. So we're gonna use this BF students in the following parts. And then this part, they teach you the right function. So this is what the function would look like. This one is it starts with the definition because you are defining a function by yourself. And then this one is your function name. You can change it as you wish. You can change it to any. Just when you run a function, you need to write the same thing. And then this one is the argument of your function. So function, remember, is something like this. So this one is called function, and then you see that there's some argument here, right? Contains in this round bracket, and also the same here. So following your name is your argument. So you define your first argument as your data, and then second argument as your starting index, as your starting point of your systematic sampling, and then a step is how you're gonna divide your population, and then you close this column, and then here, like these parts is the contents of your function. So you're gonna define an index here. Index is a variable that stores this value. So we're gonna generate and arrange. So this arrange and arrange it comes with the NumPy library. So it's which gives us an array. So this we have a starting index, and then your last point, and then by steps. Let's see this function. So let's say that we start with 1, and then end with, because this is called length data. It will measure how long is your data. So also a number, and then step equal maybe to 2. Then it will give us 1, 3, 5, 7, because it starts with 1, and then end with 8, but our step is 2. So 1 plus 2, 3 plus 2, and then the largest number is 7, because 7 plus 2 is 9, so it's the plus 8. So we would just get 8. So it will give an array like this, and if we try 3, it's the same. Because it's 1 plus 3, and then end with 7 here. And if we do 9, then maybe 10. Okay, so it's a plus. And this one will give us 10. Because I think this one is not included. Maybe on the starting is including, but the ending is not included. So this one is the contents of a function. And the next step, because here index, we are selecting, let's see, if we have here, we got 15 students, right? If we got 15 students, and then if we want to select 5 students here systematically, and then the starting point is 1, then we have 1, 4, 7, 10, 13. So this one is your index, and then index is like your ID. And then if you do this, data ilog is your location, right? ilog. So log is you are doing the value here, but ilog is you doing the number here. So that's the difference. It's also in your previous lab. So if you select this, then you obtain your sample. And then so this return function, you also need to write it, because because you are defining a function, so it returns the mapping sample here. That means that if you run this function, then your output will be this systematic sample here. So now we're gonna try how this works. We also do this. So systematic sampling, we need our starting point, right? We need a starting point. So the first thing we're gonna do is to randomly select our starting point. So if you do this, it will give us a 1. So our starting point is 1. So this one, this means the second person, because the Python star is 0. And then we define this interval we need. That's the step here. Because we now have 15 students, the whole population is 15, and then we need 5 samples. So the interval length we need is 3, right? So this one, that's actually equal to 3 here. And then now we can use this systematic sampling. We just defined this function in the previous part. You see here, we only select students that IDs here. Because if we use this, if we run this here, it will only return to the ID here. We only select the IDs. You can check in the algorithm to do it. So you just define the systematic sampling function here, and then remember you got 3 arguments here, right? So we need to give value to every argument. So we give this data argument our student's ID here, and the starting point, we just sample it right here. We just got our starting point here, and then we give their starting index a value, and then that's equal to 3 because we got 15 population, and then 5. We need 5 samples, so the steps here is 3. And we print this, it will give back the student ID we just select. So the systematic sampling, the only random factor here is the starting point. So we only do this random here. So the practice questions ask you to select a systematic sample of 3 students, and then in this way we still got 15 students. That's our whole population, right? And then we need 3 samples. So now our steps, our interval length will be 15 divided by 3. That's 5. So we need to change the steps to 5. So first steps, we also define our new starting point. We just copy this and then paste it here. But now we need to select an interval length 5, right? So we need to change this. Because here the interval length is 3, right? 0, 1, 2. There's 3 students here. But now OK equal to 5, so we need to change to 4 here. 0, 1, 3, 4, 0, 1, 2, 3, 4. So there are 5 numbers here, and then we also do this rand8. So rand8, this function just gives us a random integer here. If we print this, my seed is 10. So if you set a random C to 10, you should get the same result here, 4. So now our starting point will be 4. And then you do the same thing, the systematic sampling, but change this function to 5, you get this result. The next one, you do the stratified random sampling. So here we are defining a new sampling here. Also the ID, you see we got 8 students, so start with 1. And then this one is not included, so 1 to 9. Because you want 1, 2, 3, 4, 5, 6, 7, 8, right? But 9 is not included, so the endpoint should be 9. Because if you do 8, then it will not be included, so you should do 9 here. And then we got the sampling. Yeah, okay, ignore this. It's just a run for how to build a data set. And so this one, if you don't want to type a lot of stats and math here, you just type this one list and then times 4 plus math. And so this times 4 and give a full list here. And then stratified sampling, I will show you a figure. So stratified sampling is here we got the whole population, and then we just classified it. Like we stratified it into groups first, and then from each group we do the sampling. So we group it first, and then do the sampling here. It could be proportionate and also like this portion, like this proportion. But those are okay. Just depends on how you want it. So first we just group it, and then we do the sampling. So here you can see that we first select the program, like the stats program student, right? So these, like the sampling only contain the stats student here. And also for next one, it's the same way. So first one, DF stats, we only select the stats student, and then if we want to stat student, therefore stat student here. And then we use this random sample function. So we select 4 number, we select 2 numbers from 0, 1, 2, 3. This range 4 would give a array 0, 1, 2, 3. And then we select 2 numbers from this 4 number. So this one is a random number here. Prepare this. It will give up 0 and 1, right? So this one is your index. And then we use this unlock function again to locate the rows. Because we are selecting the first row and the second row here. So we will return this. And also the same for the next one, we grouped these people by mass. So these people are all belongs to mass department. And then we also do the same thing. We select the random rows from 4 number because there are also 4 people in the mass. And then we do the same thing. We use ilog function to locate their rows. So we'll give this. We can run it here to see what's this random number they generate. So they generate 3 and 2. So correspond here. It should be the 4th column and then the 3rd column, 4th row and then 3rd row. So 7 and then 6 here. You can also use another way to do it. But so the previous part, they are very understandable, like very direct. You just group people first, and then random, and then select random people. And then this one, you do it in one, like just one code. So we're gonna do this. We're gonna use this function group by. It's just what it means group by. So we're gonna group the original data sets is group here. In case, this one is original data set, and then we're gonna use this variable program to formulate a group for this data set, and then group is equal to false. That means that if you do it to true, then it will have those names here in the last part. But if you do it false, then the only difference is there's names here, and then there's no like program names here, if you can see. But it doesn't affect if you don't have these like this argument. You can just delete this. It doesn't matter because the right part is the same. Doesn't matter. And then you use this function, apply function. Apply function is like you are okay. So this one in the brackets, you are defining a function here. Because remember lambda. Last week we said if you define lambda here, let's say maybe lambda. Lambda x1, and then forget it now, sorry. So now we group by the program here, and then this one apply x. So x now we stand for just the data frame here we got. Like one is the data sets, and then one of them is the data mass. So x will stand for this, like the sub data sets, and then we're gonna sample this data from this data sets and two sample each. So that's what it means when apply the sample function to each sub data sets. And then I can change it to choose, doesn't matter. And also, we're gonna demonstrate how to do the unequal number in each strata. It's disproportionate. So we got a new data frame here, and then we only got 2 staff people and then 6 math people. So it's unequal observation, unequal population here. So we're gonna change the number of sample we want from each department. So we want to do it evenly. So because there's 2 to 6. So this portion should be 1 over 4 and then 3 over 4 here. So this means that we have to select 1 person from stats department and then 3 person for math department. That's what it means. So the first way we're gonna do the simple way. We're also gonna stratify the data frame first. We divide it into the stats people and the math people here. And then we do the same thing. We just select random number here because we only got 2 people in the stats department. So we select select one number from this 2 number. And then use unlock function to identify the place. But we got 6 math people here, so we're gonna select 3 samples from these 6 numbers and then use unlock to identify the people here. We're also gonna do this. Just one line code. So if we print this, we print all this here. We copy paste here, and then we change your number here because you see M here should be your the number of samples that you want. So you want 4 people, and then the length X is your sub data sets. The length of your sub data sets. So for math people, you have 6 people here, and then for stats people, you have 2 people here. So the length X should equal to 2 or 6 or 2, and then you divide it by the whole data frames length. Then those should be 8. So here you got 3 and then 1. So here x.sample we select either 3 people or 1 people because in the previous part it's even, so we select only 2 people from each department, but now it's uneven data sets, so we select 3 and then 1. So the things are the same except for this. So this, in this case, the X here will stand for the sub data sets. Sub data set. That's the smaller parts of your data sets. First part only contains math people, and then the second part only stats people. That's what it means. Okay, next part. We're gonna do some example in cluster sampling. So cluster sampling is different from the stratified sampling because in stratified sampling you divided their population according to their genres, right? It's stratified. So they might have some common place. For example, they are both stats department, they are both math department, so you know how to divide them, or they are all female or they are all male, so you know criteria to how to divide them. But now cluster sampling, so in each cluster contains all kinds of people. So you just cluster, cluster this population, and then maybe one cluster contains different people, stats, math department, and female, male. So they are different people in clusters. And then the random take place in the cluster. So we're gonna randomly select the cluster. So if you can tell the difference here we have different group here, because we stratify the population. And then from each group, we randomly select the samples from each group. For now, we just randomly select the cluster. So the darker color here is the randomly selected clusters here. So that's the different parts. It's from group, we select random people, and then we select random group. That's the difference. So here we're gonna build a data frame, but you can also use the old data frame. You don't have to type all these. You just type this the students, because we got data frame here. We got that from here. So you can use this one. You don't have to build a new one. So now we also got index, gender, faculty, and then the question asks us to we're gonna take SRS, that's random sample sampling, and then we select 2 groups. And then for all the people in these 2 groups, we're gonna select it because the cluster we select is a random one. And then all the population, all the people contained in the cluster that were selected are our samples. So we're gonna do this SRS. So this one is simple random sampling. We just select from faculty names. We select 2 samples from faculty names. So if I run this, it gives us science and music department. It might be different because our data frame may be different, but it's fine. It's just how you do the sampling. So now, cluster. Oh, okay. So in this case, we cluster every student based on the faculty. So each cluster stands for each department here, each faculty here. So we clustered it by faculty, and then we randomly select 2 faculties. Then all the students in that faculty will be our samples. So that's how we do it. If we do this, because we are selecting the faculty, science faculty, and then music faculty, then we're gonna do this. This will give us a Boolean value that's true or false. Because the 5 observation and 7 observation here belongs to the science faculty, so here's true. And then we also do this second equation here gives us the index of music faculty 1. So the second observation and the 4th observation they return 2, and then we use this. It's called OR. We use this OR. So the first one, the science one, or the music one, we combined it. So you see that this one, the true value one, will be the students either in music faculty or the science faculty. So if we do this, we select their IDs, and then we add the index here. It will give us 2, 4, 5, 7. So it will give us the students in these faculty. So we are selecting the cluster here, and then we need all people in this cluster. So this one is the same. If we use this function to list, then it will give a nice way to look. But it's the same. So this one is the sample we selected, containing the cluster of music and the science faculty. Because in this case, we are clustered the population by the faculty. So it depends on the question. If the question asks you to cluster them by gender or something, it will be different. But sometimes the clustering, we'll just look at the question, like how they ask you. Or sometimes they just cluster people randomly, but sometimes they cluster people by some factor. So just look at the question, like how they ask you. But so in this question, they ask you to cluster the population by faculty. So each cluster will stand for the faculty, and then we just select the faculty randomly, because here is the random part. Here we select the faculty by random. So that means that we select the random clusters here, and then all the people in this cluster are contained in our sample. This is cluster sampling. It might be in your assignment, but I don't know, maybe the next assignment. So just practice it yourself. Okay, that's the lab for today.